Hi, let's talk about autoscaling systems, a critical concept in cloud architecture that helps application dynamically adjust resources based on traffic. Whether you are running an e-commerce site on a Black Friday or a viral social media platform, autoscaling ensures your system can handle traffic spikes without crashing while optimizing costs. So let's jump right in. First of all, what is autoscaling? So autoscaling allows a system to automatically increase or decrease its computing resources based on real-time demand. Instead of over-provisioning resources and paying for unused capacity, or let's say risking downtime by under-provisioning, autoscaling helps strike the perfect balance between cost and performance. This is especially important for cloud native applications, which can see either unpredictable or fluctuating traffic. Think of a news website during a major event or an online store during a flash sale. Without autoscaling, systems would either crash from traffic overload or waste resources during idle times. Now, before diving deep into autoscaling, let's first break down the two key types of autoscaling. First, we have vertical scaling, which means increasing the power of an existing server, that is adding more CPU or more memory or more storage. Then comes horizontal scaling, which involves adding more server to your pool as traffic increases. So if we talk about the pros and cons, the benefit of vertical scaling is simplicity, as you don't need to manage multiple servers. However, it comes with limitations. There's always a maximum capacity a single server can handle, as a result of which you lose redundancy. Plus, it introduces a single point of failure. If the server goes down, the entire application could be impacted. Horizontal scaling, on the other hand, gives you more flexibility and redundancy, since even if one server goes down, others can take over. However, managing multiple servers means added complexity, which means you need to ensure that proper load balancing mechanism is applied between them. So, how does the system know when to scale? Here comes the concept of metrics-driven scaling, which relies on monitoring certain key metrics like CPU usage, memory consumption, and network latency. When these metrics cross a predefined threshold, the system adds or removes resources. For example, if let's say CPU usage stays above 70% for a given time, autoscaling kicks in to prevent performance degradation. This is called threshold-based scaling, and it's the most commonly used approach in cloud systems. Further, in this, we even have reactive scaling, which responds to traffic changes in real time, and predictive scaling, which uses historical data or traffic forecast to predict whether extra resources will be needed using machine learning models, or even let's say scheduled patterns to anticipate future traffic and scale resources accordingly. For example, a retail site might scale up automatically just before a Black Friday sale to handle the expected surge in traffic. Its biggest advantage is you minimize the risk of cold starts, that is, situations where traffic increases too quickly and the system can't spin up new instances in time, leading to higher latency or even outages. But what happens when traffic is unpredictable, like during a viral social media movement or a news site's breaking story? In these cases, traffic spikes can be hard to predict and scaling needs to happen almost instantly. Systems often handle this by buffering requests in queues and using load balancers to eventually distribute the load across available servers. So buffering and load balancing work together to ensure traffic spikes don't overwhelm your system. If not optimized correctly, autoscaling can lead to over-provisioning, where you pay more for resources than necessary during low traffic periods. So basically, cost optimization is the key here, and cloud providers often provide tools that help you fine-tune scaling policies to strike the right balance. Some popular platforms like AWS EC2, Google Kubernetes Engine, and Microsoft Azure Autoscale offer robust autoscaling solutions. Each of this comes with its own tools to manage scaling policies, from basic threshold-based scaling to more advanced predictive scaling options. So yeah, that's it for the day. Hope you understood the concept of autoscaling system.